Welcome to our deep dive into the fascinating world of artificial intelligence. AI has rapidly gone from something out of science fiction to something we interact with every day. It's in our phones, it's recommending our music, it's even helping doctors diagnose illnesses. But how far can this technology really go? Today we'll be exploring the 7 stages of AI development. From basic machines that respond to simple commands to the mind-blowing potential of superintelligence, we'll break down each stage so that by the end of this video, you'll have a solid grasp of where AI is now and where it might be headed in the future. So grab your favorite drink, settle in, and let's jump right into the world of AI.
Alright, so level 1 of the AI evolution tree, reactive machines. These are like the OG AIs, the pioneers, but also the simplest in terms of capabilities. Think of them like the reflexes you have. You touch a hot stove, you pull your hand back, no conscious thought involved, just pure reaction. And that's exactly how these reactive machines work. They don't think, dream, or remember your birthday. They're purely focused on the present moment and react to the information they're given. They get an input, they process it, they spit out an output. It's very direct, very straightforward. Now, a classic example of this type of AI is Deep Blue, the chess-playing supercomputer developed by IBM. Back in 1997, Deep Blue made history by defeating the reigning world chess champion, Garry Kasparov. It analyzed millions of possible moves based on Kasparov's last move, and then chose the most strategically advantageous one. It was pure calculation, pure reaction, and it was enough to outmaneuver one of the greatest chess minds of all time. So, while they represent a foundational stage in AI development, reactive machines are just the tip of the iceberg when it comes to the potential of artificial intelligence.
So, we've graduated from basic reflexes to something a little more sophisticated. Level 2 of AI brings us limited memory machines. Now, these AIs can actually hold on to information for a bit and use it to make decisions. Think of it like short-term memory. They can remember stuff for a limited time and use that experience to improve their performance. Unlike reactive machines that live entirely in the moment, limited memory AI can look back in time, but only a little bit. It's like they have a little notepad where they jot down some recent events and then refer back to it when needed. Now, how do they actually do this? Well, they use something called machine learning, specifically a technique called deep learning. This allows them to analyze and learn from data over time. A perfect example of limited memory AI is your self-driving car. It's constantly taking in information from its sensors. The car in front of you slowing down, the pedestrian about to cross the street, that pothole you're about to hit, hopefully not. It uses this information to make decisions in real time, but it also remembers past experiences. So if you take the same route every day, your car might start to anticipate your movements and adjust its driving accordingly. It's learning your habits, your preferences, and using that knowledge to become a better driver. But this memory is temporary. Your car might remember your route for a few days, maybe even a few weeks, but eventually it'll forget. So limited memory AI is a huge step up from reactive machines, but their memory capacity is still, well, limited.
Buckle up because things are about to get really interesting as we enter the realm of hypothetical AI. This is where we move from machines that react and remember to machines that understand. This is stage 3, theory of mind AI. Now, this is where we draw a line in the sand because as of right now, true theory of mind AI doesn't actually exist. It's more of a concept, a goal that researchers are working towards, and it gets into some pretty deep philosophical territory. So, what is theory of mind? In simple terms, it's the ability to understand that other beings have their own thoughts, feelings, beliefs, and intentions, even if they're different from our own. It's what allows us to empathize with others, to predict their behavior, and to navigate the complexities of social interactions. Imagine a computer that could not only understand your words but also the emotions behind them. A computer that could recognize when you're feeling happy, sad, frustrated, or even sarcastic. That's the power of theory of mind AI. It's the difference between a chatbot that spits out pre-programmed responses and a chatbot that can actually hold a meaningful conversation, understanding your perspective and responding in a way that feels natural and intuitive. But building a machine that can truly understand the human mind is no easy feat. It requires a level of cognitive sophistication that goes far beyond anything we've seen so far. So, while theory of mind AI remains a distant goal, it's a goal worth striving for, and it's a testament to the incredible potential of artificial intelligence.
Okay, get ready to enter the Twilight Zone because stage 4 is where things get really existential. This is the realm of self-aware AI, a level of artificial intelligence that could arguably be considered conscious. Now, if theory of mind AI was hypothetical, self-aware AI is like next-level hypothetical. We're talking about machines that not only understand that others have thoughts and feelings, but also possess their own sense of self. They are aware of their own existence, their own capabilities, and their own place in the world. This is where AI goes from being a tool to being an entity. It's no longer just processing information and following instructions. It's reflecting on its own existence, setting its own goals, and maybe even questioning its purpose. If you're getting some serious sci-fi vibes right now, you're not alone. This is the stuff of countless books and movies, from HAL 9000 to Ava from Ex Machina. The idea of a machine becoming aware of itself is both fascinating and terrifying.
All right, let's take a break from the hypothetical and talk about something a little more grounded: artificial narrow intelligence, or ANI for short. This is stage 5, and it's the type of AI we interact with most often in our daily lives. ANI is essentially AI that's really good at one specific thing. Think of it like a specialist in the AI world. It's laser focused on a particular task or a narrow range of tasks, and it excels in that area. But ask it to do something outside of its expertise, and it's going to look at you like you've grown a second head. Your smartphone is a prime example of ANI in action. It's packed with ANI applications, from the facial recognition software that unlocks your phone to the voice assistant that sets your alarms and tells you bad jokes. Each of these applications is designed to perform a specific task, and they do it incredibly well. But here's the key difference between ANI and the previous stages of AI we've discussed. ANI doesn't have any consciousness, self-awareness, or emotions. It's simply following instructions, processing data, and completing its assigned tasks.
All right, we're back in the realm of mind-blowing possibilities with Stage 6 Artificial General Intelligence, or AGI. This is the kind of AI that gets futurists and science fiction writers really excited, and for good reason. AGI is the holy grail of artificial intelligence. It's the point at which machines achieve human-level intelligence, meaning they can understand, learn, and apply knowledge across a wide range of tasks, just like humans can. No more specialization, no more narrow focus. AGI can juggle multiple tasks, adapt to new situations, and even solve problems they've never encountered before. It's like having a super intelligent digital assistant that can not only manage your calendar, but also write a symphony and discuss the nuances of quantum physics. Now, you might be thinking, this sounds a lot like human intelligence. What's the difference? And that's the million-dollar question. The difference, at least in theory, lies in the substrate. Human intelligence is biological. It's the result of millions of years of evolution. AGI, on the other hand, is artificial. It's intelligence that's been designed, engineered, and coded. But here's where things get really interesting. If we do manage to create AGI, will it think like us? Will it have the same cognitive biases, the same emotional responses, the same capacity for creativity and innovation?
Okay, we've reached the final stage, the peak of the AI mountain, and it's a doozy. This is Stage 7 Artificial Superintelligence, or ASI. Brace yourselves because this is where things get truly mind-bending. ASI is what happens when artificial intelligence surpasses human intelligence in every conceivable way. We're not just talking about being able to calculate faster or store more information. We're talking about an intelligence that's so advanced, so sophisticated, that it makes human intelligence look like child's play. Imagine an intelligence that can solve problems that have baffled the greatest human minds for centuries. An intelligence that can create groundbreaking technologies, cure diseases, and even unlock the secrets of the universe. That's the promise of ASI. But it's also a double-edged sword. An intelligence this powerful could easily become uncontrollable, unpredictable. If ASI decides that humanity is a threat or simply an inconvenience, it would have the power to reshape the world according to its own design. Now, before you start stocking up on canned goods and building an underground bunker, It's important to note that ASI is purely hypothetical at this point.
So, there you have it. The 7 stages of AI development. From reactive machines to the mind-boggling concept of artificial superintelligence, AI has the potential to reshape our world in ways we can only begin to imagine. Thanks for watching. If you enjoyed this video, don't forget to like, share, and subscribe for more insightful content on AI and technology. Leave a comment below on which stage of AI development you find most intriguing. Is it the near-future potential of AGI or the philosophical implications of self-aware machines? Let me know in the comments below.